All right, thank you, Rochelle. Hope everybody is staying safe, and good morning and good afternoon to all of our attendees. Today, we wanted to talk about wireless install on Nebula and how to make sure that your installation goes smoothly. Some of the topics we'll be talking about in this webinar are not only just the installation, but also some troubleshooting issues that might occur while installing your wireless access points. So we'll be going over some of the pitfalls that does occur sometimes when installing your Nebula installation, going over what we can do to try to figure out what's going on with any type of wireless connectivity issues we may be having, and just going over a general overview of anything that may crop up as a part of doing your install. So first, we're going to start with the Nebula Wi-Fi installation itself, basic onboarding of getting your AP installed into Nebula. Next, we'll look at the dense Wi-Fi deployment scenario where you have, a lot of Wi-Fi clients trying to connect to your access points. Thirdly, we'll look at the school deployment scenario where you're trying to install this in a school and any pitfalls or maybe troubleshooting that may need to happen in that installation. And then finally, just some basic troubleshooting with the wireless itself. So basically, to get started, what I'm going to do is I'm going to log into one of our Nebula portals that we have set up. So let me go ahead and bring that on right now. Give me just a minute. Okay, so we should see the Nebula dashboard on my screen here. So when it comes to installing your Nebula access point, one of the first things you're going to want to do is basically grab the serial number and the MAC address to onboard your device. So you're going to go to your site once it's already installed. We'll just go through it really quick, but you go to your organization-wide and you go to your license and inventory. And then your license and inventory is going to be the section where you can install your devices. So what we have here is we have our overview that gives just a general overview of all of our devices. I have no firewall security gateway license on this particular organization right now, but if I go over to my devices, I can go over here to add our specific access points. So we just go and click on add. You enter in your MAC address and serial number of your access point. And once that's done, then it's in your inventory and then you can assign it to a specific site. So I have one site here called our Office Lab that has multiple access points and also a USB Flex and an NSW. So once it's in your inventory, you basically can just install it to whatever site you want to install it to. Once the access point is on your site, what we can do here is go to our SSID settings. So you go over to access point, go to configure, and go to SSID settings. So with your SSID settings, you're only going to see 2 SSIDs by default. That doesn't mean that there's more SSIDs. It just means that it's going to hide all SSIDs that are not broadcasting. If we go to show all, we'll be able to see all of our access points SSIDs that are available. Now, with our access points, you can broadcast up to 8 SSIDs per radio. So that's going to be 8 SSIDs on 2.4 gigahertz and then 8 SSIDs on 5 gigahertz. So if you do not need to see these access points SSIDs, we can go ahead and click on the option to hide disabled ones. So this green checkmark box means that the SSID is enabled. So if I were to enable this SSID number 3 and save it, and then go back to hide disabled SSIDs, we will then see here that these are the 3 SSIDs that we will be able to see on our main screen. Moving along here, we have the option for simple mode up at the top. So simple mode basically will just give us only just the simplicity of items that we need, basically going to be your SSIDs and your WLAN security. So that's basically what it means. A simple mode, it just gives you those 2 options on changing these particular settings. But if you need to do advanced, if you need to set VLANs, if you need to do a little bit more programming, you'll see that this section here, the SSID advanced setting, opens up and allows you to go ahead and make further adjustments and refinements to your SSIDs. So for instance, if you want to enable WPA3 if it is supported on that particular access point, you can. You can choose to use dynamic personal free shared key based on the monolith that it's available for. You can do MAC-based authentication. You can do a sign-on method. So there's a lot more information and tools available to you by going into the advanced SSID settings. The more options are going to be your traffic shaping. So if you want to specify a rate limit for per clients that are connecting up, you can choose to do your rate limiting. And then of course down here we have our VLAN IDs. So you can put a VLAN on the SSID. You can do layer 2 isolation and intra-BSS blocking. So your layer 2 is going to prevent users from accessing other devices upstream on your network. And then your intra-BSS is going to block SSID to SSID communication between different clients. Now down here, you will see we have assisted roaming. By default, our access points when it's in Nebula will be able to roam without having to enable any other extra options. Assisted roaming is the 802.11k and V standard along with the 802.11r, which will then help with any type of roaming issues. So here comes the troubleshooting debate right here. If you run into any issues where you're finding clients are having difficulty roaming from one access point to another, you can choose this assisted roaming option here, which will help with all of your roaming needs. So this is your basic onboarding for getting your access point set up to broadcast an SSID with a pre-shared key enabled if you choose that method, or if you want to do a sign-on method. And then we have our VLAN settings for that particular SSID, and then we have our rate limiting. So now let's go ahead and talk about different scenarios. So let's just say that you have your access points and you're going to install this in a hotel environment that has a convention center. In the convention center, there's going to be at least 200 people that are going to be at this particular convention, and you have been tasked with putting an access point in the convention hall. So with our access points, we normally suggest anywhere from 35 to 40 users per access point to get the best Wi-Fi experience. So with that being said, that means that in an environment such as that, you're looking at adding up to at least a minimum of 4 access points. However, because the venue area is such a small space, a lot of these access points are going to be pretty much on top of each other in terms of coverage. These access points, what we use as a general rule of thumb is that they broadcast 125 feet in all directions, clear line of sight with no obstructions. And that's just a basic guideline that we go off of. However, let's just say that this particular venue is only 200 feet in length, or maybe it's 200 by 200. So if you plop one access point in there, it can cover most of that. However, you're going to be needing up to 4 access points, and that means that your access points are going to be bleeding over with the radio. So one of the things that we can do here is if we come over to our access point and we go to radio settings. Let's see, I haven't saved my settings here, but we're going to go straight to the radio settings. You'll see here that we have the maximum output power. Now, this is a new feature that we added where we have different templates that are already embedded into Nebula. So this means that if you have a high density deployment where you have a lot of clients that are going to be connecting up in a small space, if you put it on a high density deployment, it'll automatically lower your 2.4 and 5 gigahertz dBm to 12 and 15 respectively. Now your 5 gigahertz is going to be a little bit higher, about 3 dBm higher, mainly because with 5 gigahertz, even though you have a faster connection with the 5 gigahertz, the radio waves do not propagate as far. So therefore, you're going to need a little bit more power over your 2.4 in this particular deployment. Now, we also have a moderate, which is going to be 15 and 18, and then we have a low density deployment, which maxes out the power output on both the 2.4 and the 5 gigahertz. Now, if you want to put in a custom setting, you can come down to custom and you can enter in from the drop-down list what you would like your dBms to be. Now, in terms of what option or what power setting that you should set this to, it's really going to depend on the environment. You're going to need to use a Wi-Fi analyzer like Insider or any other tool that's available either in the App Store or in the Google Play Store that allows you to see the SSID strength in dBms when you're connected to it. This means that when you are installing one access point, you're going to connect to that access point, and then you're going to walk the property while connected to that particular access point. You're going to look and see how far you can get with that access point before you feel the need for it to switch over. And this is something that we're going to talk about in just a moment, because when it comes to Wi-Fi and it comes to roaming, different clients will have a different set of roaming aggressiveness. So iPhones and Androids, their Wi-Fi chipset will have roaming aggressiveness kind of built into the software of the device. So that means that even though your connection may show low signal, it may want to hold on to that particular access point until it roams to another one. Now, we do have the ability to kind of facilitate the roaming capabilities by having the access point tell the client when to disconnect. So once you've set your DBM to how you feel it should be at, like if you're going in between two access points, access point 1 and access point 2, and you feel that, okay, we're going to set it to maybe 10 dBm and then 13, and you find that that's a real good compromise in terms of the power, we can then go over to access point, and then we can go to, let's see if it's here. Sorry, it's going to be right here, smart steering. In the access point in the radio settings, we have smart steering. So if we enable smart steering and go to the advanced options, we can now choose when the access point will kick that particular client off of that particular access point itself. So we have two options here. We have the signal threshold and the disassociate station threshold. So these are the two numbers that you're going to work with in both the 2.4 and the 5 gigahertz. So a good starting point would be around -70. Start with your signal station threshold, and your disassociation station threshold, we would suggest setting it to -75. Now, just to get a good start. Now, the reason being is that when a client hits this particular threshold of -70, what that means is the access point will then tell the client, or actually disassociate that particular client. This is basically the threshold where it knows to basically disassociate it. The disassociation threshold here, even though it says disassociation, basically means if it drops down to this, this particular dB rating, this dBm, that device will be prohibited from trying to connect back to this particular station. So this is kind of like a hard cap. If the client's device goes down to this particular dBm, then that means that they will not be able to try to associate to this particular device. Once you hit -70, though, even if you're connected, you're going to force the access, force the client, the access point will force the client to then roam and look for another access point in the area. Now, if it's not able to, it will try to reconnect back to this particular station. But once it hits -75, then again, you're going to end up having it being inable or ineligible to reconnect back to that particular access point until the numbers are more favorable. Now, for your 5G settings, for your 5 gigahertz settings, again, you want to offset it by about 3 dBm from your 2.4. So we'll set this to -73. I'm sorry, it's actually in the wrong direction. It is -67 and -71, or sorry, -72. So we're going to offset it by -3 for the 5 gigahertz and the, a little lower. And then we're also going to keep that 5 dBm separation. So these are some good numbers to start with. So if you're having any type of issues where clients are not roaming properly, the first thing you're going to want to do is check, again, up here. First, check your power settings. Make sure that your density deployment matches what you're trying to do in your environment, and set your dBMs properly for APs that are basically on top of each other. And then the next thing you're going to want to do is come down to your advanced options for your smart steering and adjust your smart steering values. Now, you're going to have to play around with these values a little bit. I mean, there's no magic bullet that will fix everything, but this is a good starting point for your environment. So you'll have to walk the environment, check the numbers, and make sure that your roaming is more seamless. You have a good handoff and you don't have any dead spots between your access points that you're trying to roam to. Now, another thing that I do want to touch on real quick is going to be the DCS settings. It's going to be a dynamic channel selection. We've gotten, multiple calls from customers who called in and said that they're finding that the environment that they are installing their access points in also has access points that they don't have control over. So these access points may be broadcasting on a channel that you're using, and it's going to cause interference. So this is going to be the source of some slowdowns, or it's going to be a source of dropped packets in your network. So if you have a customer that complains about, slow speeds, or they're, coming to you with an issue where they're finding that, the packets are being dropped, or just an overall slowness, you're going to want to check your DCS, which is your dynamic channel selection. So with dynamic channel selections, our access points will probe the environment to see what other sources of interference or other access points are broadcasting on a specific channel. The DCS will then choose a channel deployment. You can choose a 3-channel deployment, a 4-channel deployment, or a manual channel deployment, where it will then look at the environment and try to broadcast on a channel that is not overlapping with the channels that are being broadcast in the environment. We have an option to do a DCS schedule. We have the DCS time interval. I would highly suggest not to use the time interval because you can set it to 720, which is going to be your 12 hours. So you can have it check every 12 hours, but that's probably not a good idea because, let's just say that in the middle of the day, the interval comes up, it's time to check everything. So then all your access points will then have to be disassociated with the clients to check the environment to then change the channel if needed be. What we suggest to do is setting a schedule and having it set to a specific time before your business opens. So if your business opens at 8 o'clock, you want to run it at maybe 7:30 or 7 o'clock. And that'll run every morning at this particular time to check the environment to see if there are any other sources of interference and the best ways to avoid them by changing the channel. So that means that when your employees come to the office, that means that the devices have already been set up with the proper channel, and that this should eliminate most, if not all, of your interference from other devices that are broadcasting. Another option here is going to be your DFS, which is your DFS channels. You want to allow this to be on. So you want to avoid 5G DFS channels. So your DFS channels are going to be specific channels in the 5 gigahertz spectrum that are licensed by the government. And by FCC ruling, if you broadcast on that channel and it's needed, the AP has to be shut down for up to 30 minutes. So the radios get turned off. So if you're finding issues where your 5 gigahertz SSIDs or your APs just suddenly drop off and they're not broadcasting, you're going to want to check to make sure that you're avoiding your 5 gig DFS channels. So that's going to cover it for your basic hotel installation. Next, I want to talk about your school installs. So when it comes to putting access points in schools into classrooms, one of the things that we tend to see more often than not is that these classrooms are capped with a specific amount of users. So you have 30 kids in a classroom and you have a teacher. So if we go over here to access point and we go to AP port settings, we're going to have an option for load balancing. So with load balancing, we have 2 different options. We have by client device number mode and enable smart classroom mode. So with smart classroom mode, we can then set a hard cap and limit on how many devices can connect up to both the 2.4 and the 5 gigahertz. So for instance, we can set this to say 40 for each, or we can set it to, let's go down to 20. And that means that the devices, you get 20 devices on 2.4 and 20 devices on 5 gigahertz. So if anybody tries to connect up after this hard cap is reached, they will not be able to connect to this access point. They'll be forced to roam to another access point in the area. However, if you only have one AP in the classroom, that basically means that it's going to be first come, first serve, but it shouldn't matter because in this particular smart classroom mode for e-learning, when you have specific devices that are bound to a classroom and you know that there's only going to be 40 devices total, then you know that this is going to work out because only those devices in the classroom should be able to connect up to the access point. This also prevents any bleed over. You won't be able to roam to any other classrooms because all of these will be capped out based on the amount of devices for that particular classroom. Now, conversely, we do have another option, which is enable by client device number mode. So when you set a hard cap on this section, there's an additional option to disassociate client when client device when overloaded. So what this means is that once you've hit this cap, the next person that joins, it will look at the table, the association table, and then it will remove the client that has been on the longest. So if a user has been on for, say, 4 hours and they have the oldest aged account, they will then get removed from this and they'll be forced to look for another access point to roam to. So you do have options here. You can combine this option along with some of the other options that we talked about earlier, such as your setting your DBMs to the proper level, and also setting the option for your power management, so that way you kind of tighten up everything with roaming, so that you can say, okay, I only want X amount of clients connected to this particular access point, but if it gets overloaded, force them to look for another access point nearby. So this can work in a non-classroom mode. It is very useful when you want to cap out the particular amount of devices that are able to connect to an access point, and thereby force users to roam to another access point should it get full. All right, next I want to talk about an option here called wireless health. This is a Pro Pack feature, or Plus or Pro Pack feature. If we go to wireless health, we can look at a particular access point, or all of the particular access points, and we can see how their connectivity is. So at this particular moment, there was only one access point that's available in this particular network, but we have a graph here that shows that basically this particular access point, when devices are connected up to it, you'll get a scatter graph that shows you how well the connectivity is for that particular AP. So let's go back and look at the past 30 days. We can see that there is a particular client, particular access point that has been showing fair, poor, a little bit of fair, a little bit of good. So it's kind of all over the place. You'll see that, this particular AP is showing that, we're getting a lot of fair signal, but not really good signal to the clients. And we can see the actual device model. If we wanted to take even further, we can go to the last 30 days and we can actually look at the client. So we see that there's a Pixel Pro that was having, difficulties connecting to that particular access point. It's kind of all over the place, but it could be that this particular person was roaming from, away from this particular AP. But being that there's only one AP in this particular site for this particular organization, this would be normal behavior, because it looks like maybe this person roamed too far away and then basically disconnected, and then they switched over to maybe their cellular. But this is a very useful tool to use, because you're able to pinpoint clients that are having difficulties connecting to a specific access point, or a particular access point that's having difficulties connecting with the clients. So if you're seeing something like this, it allows you to investigate, well, maybe that this particular AP is not in a good spot. Maybe it's near some source of interference. Maybe we need to take a look at its placement. We may need to move it. But there's a couple of things that you can look at when it comes to looking at this particular graph. It's a very useful tool to use, again, just to give you an overview of what the APs are reporting. Just in case if somebody, client says, okay, well, I was connected to this particular SSID. Okay, well, you look up the SSID, look up the MAC address. Maybe it's in a specific room at a hotel. You can look at it. You can determine, okay, well, this belongs to that particular AP in that particular room. Let's investigate further. Let's see why this particular user is having an issue with, maybe slow speeds, or maybe the connection is too poor. But this will help you determine those particular type of issues. Another option for troubleshooting that I do want to cover is going to be when you see slow speeds. One of the things I talked about was looking at your channel usage, making sure there's other sources of interference. However, we do have one other trick that we have when it comes to looking at access points and slow speeds. So if you go to the access point and go to monitor, and you click on your AP itself, if you scroll down on this particular page, you'll see access point usage and connectivity. So this will show you kind of like the overall view of the access points. Looks like nobody was connected to this particular AP. But you'll see something in here when you have people connected to it. You'll see something called channel utilization. Your channel utilization will start low, and then as more people are connected to it, it'll go up higher and higher. Usually you'll see a 2.4 and you'll see a 5 gigahertz graph on this particular page. So with channel utilization, when you see channel utilization above 50%, channel utilization itself basically means that when it comes to something called airtime fairness, so when a user connects to an access point, you have multiple users connected to the same access point, they all have to take turns transmitting data. If you're using legacy devices, older devices on that particular network, they don't support the newer technologies that help with sending packets to the AP. So the AP has to wait longer for older legacy devices or devices that are, having a hard time sending traffic. It's going to cause latency issues. So it's called airtime fairness. So those older devices have to take time to send the packets to the access point, and other APs or other clients are going to have to wait for that transmission to finish. That's basically what's going to be meant here when you see channel utilization. So the higher the number is in channel utilization, there'll be this graph here that will give you a percentage. So the higher this particular percentage is in this section, basically means that you're having issues with retransmissions of your packets, you're having issues with airtime usage and airtime fairness for your Wi-Fi clients. So that's something that's a very good tool to use to look into if you're finding that clients are complaining about slow speeds or latency issues. You want to come here and take a look at your access point usage and connectivity and make sure that the values stay below 50%. And then that's pretty much going to give you the overall view when it comes to your basic troubleshooting. Now, if you want to troubleshoot, I'll give you a couple scenarios here. Let's just say that you need to find out a particular access point. Maybe it is not responding. We have tools here. We have live tools that are available for you to use. So you can look up the traffic statistics. You can do a ping. You can do a trace route. And you can also reboot the access point if you're having difficulties with it. We also have a locator LED. Let's just say that you installed an access point, but you forgot where exactly it was installed. You can use this locator LED, which will cause the AP's LED light to flash. That way you know exactly where it's at. And then finally, we have our logs that you can go to. So if you go to access point and you go to event logs, you can view all of your event logs for the particular access points. Just keep aware and keep in mind that the logging standard follows your basic logging standard for wireless. So it's not going to jump out and tell you the exact problem, but you'll see something such as, WLAN station has disconnected or disassociated. If you're seeing issues where a device is having difficulty staying connected to an access point, you'll see in logs that the station has disassociated and reassociated over and over again. That's something that kind of points to possibly having an overlap of access points that are too close together. You may need to adjust the power options on those access points. Going back to that option again, adjusting the power over here in our radio settings, or you may need to adjust your smart steering options here. So this covers just basic troubleshooting for your access points. At this point, I want to go ahead and open it up to questions, open the floor up to questions, just to kind of answer any questions that have, I'm sure have piled up in terms of questions that need to be asked. So I'll go ahead and open up the floor to questions at this time.
Yeah, I have some questions here, Marcus. Can you hear me?
Yes, I can. Go ahead.
Okay. What is the suggested power setting for the antennas?
Okay, that's a good question. We don't have a hard, fast rule that we go by. It's going to really be dependent on your environment. So by default, 30 dBm, the max power is going to be 125 feet in all directions. So if you're going to be putting it in a small space, a good starting point would be to have this number. And of course, adding 3 dBm to your to your 5 gigahertz, so you have 15 and 18. Again, this is basically your moderate density deployment. So 15, 18, your moderate density, you might want to start off with that, but it's really going to be dependent on your environment. So if you're going to be placing this in a space that's smaller than 125 by 125, start off with moderate density deployment, especially if you're going to be using 2 access points. If you're using 1 access point, then it really doesn't matter in such a small space, unless you don't want bleed over. Like, let's just say that you are trying to cover a 125 by 125 foot area, and you also need to cover an additional room next to it that shares a wall with shares a wall with an area in there that you're trying to apply this particular access point to. Then you need to be careful of bleed over, because even though APs, the signal does degrade as you go through walls, it can bleed over. So you need to be aware of that fact and adjust your power accordingly.
Awesome. All right. Next is there any benefit to using classroom mode?
I'm guessing like over smart or just in general. The benefit is going to be that you can cap off the amount of access or amount of clients that can connect to this particular access point. So it's great when you want to control the amount of users that can connect up. You want to ensure that if you know that there's going to be 100 devices, let's just say that you have a warehouse and the warehouse has scanners, or maybe they're not mobile scanners, but they're tethered scanners, and they're attached to a computer, and that computer is stationary. You know that you only want so many scanners to connect up to an access point. Then yes, you can use classroom mode in a non kind of roaming environment. Otherwise, I would go with the other option, this one here, basically, so you don't so you can deal with roaming. So classroom mode, good for stationary when you want people to stay connected to a specific access point. This one here, enabled by client device number, is good for roaming when you want to cap it off, but you want to allow roaming to force them to connect to another access point.
Great. All right. And the next one, I saw an option for disabling legacy clients. What does that do, and what purpose does it serve?
Okay, so I believe you were referring to in the radio settings. Let me go back and take a look here. There is an option for, here it is, allow 802.AX AC in stations only, and then you have the option for legacy. So the reason why you won't, why you would do this option is if you are the IT administrator and you are in charge of the devices, you're ordering devices, you're ordering, Chromebooks or laptops, you're probably going to be ordering something that has newer technology, at least minimum of in Wi-Fi. So if you go lower than that, if you use A, B, or G, and you connect to the network, this goes back to that whole fairness, airtime fairness thing. If you use any of these technologies, it's going to slow down the potential network for the access point. So let's just say that you have a user that has Wi-Fi 6, they're connected up, somebody connects up with 802.11g, that means that the device, the AP, the speed is going to have to drop down to the G speeds in order to accommodate this particular user. And that's going to slow down the whole network, because that device has to spend a much longer time broadcasting packets, and the other devices are going to have to wait their turn much longer. They have to wait much longer for their turn in order to broadcast packets. So by turning this option here on, that basically means that these lower legacy devices, lower end legacy devices, will not be able to connect to the network. It essentially locks them out. So it's a good thing to use when you're in control of the network, but it's probably not a good option if you're going to be using it in, say, like a hotel, because there are those people who have older clients, or they have older laptops that are sporting, your BG, A, B, and G connectivity. So I would only enable this option if you are in control of the IT infrastructure and the devices that are going to be connecting in are AX, AC, or in.
Excellent. All right, the next question is, what was the name of the app you mentioned earlier for looking at the WAP signal?
That would be Insider. That's INSSIDER. It's been around for quite some time. I believe you can get it on your laptops. It displays all the networks that your Wi-Fi card can see, and it lists their MAC address, so you know that you're connected to the correct access point. And then it displays everything on a graph, and you can see your dB measure. Additionally, MacBooks have, in their airport settings, they have a meter that shows you the dB rating as well, so you can use that as an option.
Great. All right. Last but not the least, how many clients do you suggest to put on a single access point?
We suggest like 35 to 40. That's basically due to the WPA2. We want to make sure that clients have the best possible throughput, and we find that seems to be the sweet spot. That doesn't mean you can't put more APs on or more clients on the AP. We've had a customer that installed outdoor access points at a stadium for monster trucks, and they had specialized software that they used for their PA system. So you would download an app onto your phone, and then you connect to the Wi-Fi, and then you put your headphones on, or a set of headphones on, and you'd be able to hear PA announcements because the monster trucks were so loud. But in that particular instance, they were able to put 120 to 127 users on it, mainly because the PA announcements use very little traffic. The audio files use very little traffic when it's streamed. So they were able to load up the access points with the maximum amount of users. So really, it's going to depend on the type of traffic you're pushing. If you're doing like network scanners, okay, then you're just sending little bits of traffic when you scan things. So it's just going to be dependent on the size of the traffic, so you can load up a lot if it's just sending little bits of traffic here and there. But for instances where you're doing something like Netflix, Hulu, you're streaming in a hotel, you definitely don't want to put 127 users on an access point. You want to kind of spread it out. So you want to go, maybe 30 for streaming. And it's going to be dependent on if you have your WLAN controller settings. So let's just say that you go over here to the radio settings and you go to traffic shaping and you do traffic shaping, or you do the basic traffic shaping on the SSID, where you set it so that if we come over here, you can set it to per client device, and you can set the speed to say 2 megs or 3 megs per user. So if you have the bandwidth management set up, then that will really dictate how many users you can put on there, but we suggest 35 to 40 as a good starting point.
Sorry, I was on mute. Okay, another follow-up question, Marcus, I guess from the person who asked about the app. Insight doesn't show up in Google Play Android version. Not sure. What does that mean?
I think you can look for something called Wi-Fi Analyzer. That might be another option as well for Google Play. Any Wi-Fi analyzer that shows you the dB ratings, you'll just have to look in the descriptions, but most Wi-Fi analyzers will show you the dB rating of that particular access point that you're connecting to. So any Wi-Fi analyzer that shows that information is going to be useful. We just know of Insider because that's available on the PC, and some people just use the laptops to kind of roam around. But as far as Google Play, there should be something called, I believe, Wi-Fi Analyzer that will do the same thing.
All right, great answer. And that's it. That's all the questions I have. Do you have anything to add, Marcus, before we wrap up?
Yeah, actually, I do have one last thing I do want to add, and that goes back to the whole airtime fairness. So there is an option. If we go back to, let me actually come back here for a minute. Airtime fairness, I did kind of talk about it briefly, but if we come over here to the radio settings, and it's actually not going to be on here, mainly because this access point that I'm on doesn't support it. But if you have a 802 AX, so if you have the WAC 650S, the 630, the 610, the 510D, or the NWA 210AX or 110AX in your in your Nebula, you're going to see an additional option here. It's not here because we don't have one of those devices in there right now. But there'll be an option right here that will say enable fairness. And what that will do is if we go back to that section that we talked about earlier in regards to the actual access point itself, and down here, there's going to be like a little graph. But if you see this graph, it goes above 50%, and they'll tell you the percentage. If it goes above 50% right here, what you're going to want to do is go to access point. You're going to want to go to your radio settings, and then there's going to be a option for enabling your fairness. And let me see if I can actually bring up a screenshot for that. Here. Okay, so here we go. So if we go to access point configure radio settings, there'll be an option for airtime fairness under the output, maximum output option. So you'll see that airtime fairness, you want to enable it. So that basically means that whenever you see that your channel utilization above 50%, you're going to want to enable this option. Because what that'll do is it will take all of the latency that's happening with devices that are trying to connect up and send packets, and it will kind of even it out so that everybody gets the same amount of time to send and transmit packets to the access point, and it kind of evens and smooths things out. So yeah, I just want to bring that to your attention, just so you know that that option is available on our AX access points.
All right, wonderful. Thank you, Marcus. So that wraps up our webinar for today, folks. Thank you for attending, and have a great weekend. We'll see you on our next webinar. Thank you, Marcus. Thank you, everybody.
Thank you, guys. Have a good afternoon.